Hello. This video is for our blue group on Thursday and Friday, October 1st and 2nd, or our red group Monday and Tuesday. Let's see, Friday's the 2nd, Saturday the 3rd, Saturday the 4th, October 5th and 6th. So this is a little different because what we're doing in class today is a very hands-on lab. Something that you couldn't really recreate at home. You probably don't have graduated cylinders, balances, and test tubes at home. So I'm going to demonstrate this lab. Ideally, I'll be able to partner you with somebody in class and you can walk through it with them live. But if you're absent or some other unforeseen circumstance happens, this is the best we can do. You'll just have to follow along as best you can. So let me share my screen. All right, and looking at today's Canvas page, I'm just gonna go based off the blue group because they do this first. This is Thursday and Friday, October 1st and 2nd blue group. If you're in the red group, Monday and Tuesday, there'll be a different one for you. But metric, volume, and mass lab. All right, and not a lot to say here because most of this is done in class, but there is a document here, which is the actual paper of the lab. So there are Part A, liquid volume color challenge, Part B, irregular solid volume, Part C, regular solid volume, and Part D, mass. So there's kind of 4 parts to this. So for Part 1 here, the liquid volume color challenge, let me see if I can. So it would be best if you just keep this document open, maybe split your screen, have this document and this video open at the same time, because I'm going to need to use my camera to show you things that are actually on my desk. So I'm going to be stopping screen sharing now. Switch my camera. There we go. All right, so for this first part, the volume challenge, we're going to be using 6 test tubes labeled A through F and 3 different types of colored water, red, blue, and yellow, a pipette to help transfer small amounts of liquids, and graduated cylinders, a large one and a smaller one if we want smaller, more precise measurements. And we're just going to follow along and do this as best we can virtually. So I have read through these directions in their entirety already, so I'm just going to start. Perform each step outlined below using accurate measurements. Remember to use the dropper to transfer water, or pipette, and the graduated cylinder to measure. So first step says to measure 8.5 milliliters of red water from the beaker, or in this case, I just use plastic cups for safety and cheapness, and put it into test tube A. So most people will be using a pipette to do this, but I'm just awesome, and I can pretty much eyeball it. I've had a lot of practice with this. So looking eye level with the water level and reading from the bottom of the meniscus, let's see, this is 5, 6, 7, 8. And then, wait, just a second. 5, 6, 7, 8. Oh, actually, I have a little too much. So that was 9. So on this one, every line appears to be worth half a milliliter. So you can use a pipette to remove a little bit. It says 8.5 milliliters. And it says to put that in test tube A. Okay. Measure 10.5 milliliters. I'm gonna tap out the excess liquid. There's still a little in there, but so be it. Measure 10.5 milliliters of yellow water from the beaker and put it into test tube C. So now I need 10.5. This is going to be one small line above the 10. And again, I am awesome. So I just happened to get that right on. My meniscus is right at that one small line above the 10. And again, each of these lines is worth half a milliliter. I'm going to put that in test tube C. I spilled a little bit, but I'm not going to stress about it. This is water and food coloring, not hydrochloric acid. Step 3, measure 11 milliliters of blue water from the beaker and put it into test tube E. And as you can see, it turned a little green. There was a little leftover. I'm trying to make this video short, so I'm skipping steps like rinsing things out. That should be okay. And then now we're going to be moving smaller amounts of water from one test tube to another. So step 4, measure 2.5 milliliters from test tube A and put it into B. So our pipettes can actually be used to measure. You can kind of see here, they have markings for half a milliliter, 1, 1.5, 2, 2.5, and 3. So that makes measuring these small amounts a little easier. So 2.5 from A, from our red one here. It's a little tricky to get it to go all the way up that high. I'm just going to do 2 and then I'm going to do a 0.5 because I can't get it to go up all that high. I'd have to squeeze it a lot. From A into B, so there's 2 milliliters and 0.5. All right, now measure 3 milliliters of water from C and put it into D. Again, I think I'm going to do 2 milliliters and then 1 because I can't seem to squeeze it hard enough to get higher than 2. From C into D, there's 2 and 1. Oh, sorry, I just realized that little strap is in the way. That should be better. This is hard to angle the camera and do the lab at the same time. Step 4, measure 4 from E and put it into F. So I'm going to do 2 and 2 to make that easier for me. 2 and 2. Step 7, measure 2.5 from C and put it into B. Okay. 2 and a half. Step 8, 1 milliliter from A into F. Okay. 1 from A into F. And measure 2 milliliters from E and put it into D. Didn't quite get 2 that time. All right, and look what we have here. Maybe I can turn this around so you can see it a little better. Isn't that lovely? So if you make your measurements accurately, it should end up being a rainbow, like Roy G. Biv, red, orange, yellow, green, blue, violet, in equal amounts. I did this really fast, so you can see a couple of them are a little bit higher than the others, but they're close enough for our purposes. Hopefully you don't have to rush like I did. All right, and you would fill in the final color and final volume for each of those measurements. So in the interest of time, I'm telling you that if you added up all of those steps, like how much was added into and taken out of each tube, they should be the same. So in the interest of time, I'm just going to double check the volume of one of them. We got a little bit of foam there, but it looks to be ever so slightly above 5 milliliters, not quite to 5.5. Maybe let's call it 5.2. I believe what it's supposed to add up to is exactly 5 milliliters. So if I took my time and did this right, yeah, this would be 5.0 milliliters. So yeah, you'll fill in that final volume. And again, you can't do this lab at home, so the best we can do is show you what it is. But you can at least see what each color is. And we've checked that they all should be milliliters. Right, and there will be a waste beaker. I'm just going to pour a lot of this directly into the sink, though. Moving on to part B. These don't take quite as long. So this is finding the volume of an irregularly shaped solid. So using that water displacement method from our notes on Wednesday. So these directions, the objects, by the way, is dice, a 4-sided die and a 6-sided die together. That is the item we're going to be finding the volume of. So fill the second column, estimated volume, by estimating the volume of these items. I will leave that to you. In cubic centimeters, or centimeters cubed, what do you think the volume of these will be together? And you'll fill that into that first column. It's really the second, estimated volume of items. The first one would just be naming the items, in this case, dice. Then add 40 milliliters of water to a 100 milliliter graduated cylinder. So here's my 100 milliliter graduated cylinder. There's the 40. Got some water. $40. Not quite 40. 40. There we go. So that is the volume before adding the items. 40 milliliters. We add our items. It was 40 before. I will leave it to you. Wait, I gotta give you a good camera angle at least. I will leave it to you to say what it is now. Just make your best measurement you can there. I know it's a little weird because it's clear, but you'll make your best measurement you can. So you'll write down the volume after adding the items. Then you'll subtract the larger volume from the smaller to find how much the water level went up in milliliters. That is the difference in the water level before and after. And then finally, if you recall, because we said we use different units for solids than we do for liquids for volume, that last box there, you just take the previous box, the difference in water level before and after, that measurement in millimeters or milliliters, and just turn it into centimeters cubed. Same number, you just change the unit. Remember, a milliliter and a centimeter cubed are exactly the same size. For this next bit, I'll need to grab a ruler. Measuring the volume of a regular solid using that length times width times height formula that we saw from our notes. So for this, I'm going to leave you to do. If you have a printer, awesome, you can print out this page. If not, I know it won't be perfect, but you can measure with your paper ruler that you got in your science kit at the beginning of the year, or any other metric measuring device. It has to have centimeters on it to measure the length, width, and height of each side. You can do it straight off your screen if you have to, and record those. Make sure to include units, in this case centimeters. It says to go to the nearest tenth of a centimeter. So I want to see decimals like 3.1, 4.2. I'm not saying those are the actual measurements, but that's the level of detail we're looking for. And then you'll multiply them to find its volume in centimeters cubed. And make sure you use that method in the notes that we saw for how to make sure you're not accidentally measuring the same side twice. The one I liked the best was choose a corner and measure every edge that comes out of it. That way you know you're measuring 3 different dimensions. And finally, part D is going to have us practice measuring mass. So we have, let's see, 1, 2, 3, 4, 5, 6 items we're going to measure the mass of. We'll be using our triple beam balance to do that. So first, let me make sure everything's set to 0. Okay. And if this was calibrated properly, when this is set to 0, that needle should point right about at that 0. That's going to be close enough for us. All right, so the first item says small graduated cylinder. And if you recall, the way we do this, we move one mass at a time, forward one notch at a time. So see how the arrow's pointing up right now? We move them forward, starting with the hundreds place, one notch at a time until it points down, and we move it back one. So that tells us that this item, because it popped down immediately, is between 100 and 0 grams. Now, we do the tens place. Let's see, that's really close, but not quite. And at 30, it popped down. So now we move it back to 20. So now we know this is somewhere between 20 and 30. And finally, the ones place slides freely. And you got to be gentle with this so you don't move the arm around just with your finger until this balances, till that arrow points right at that line. So this small graduated cylinder appears, you add up the 3 rows, 0 from the hundreds place, 20 from the tens place, and it looks to be about 0.4 in the ones place. So this small graduated cylinder has a mass of 20.4 grams. So I'm trying to use the camera as my eyes, and it's very disorienting. That's why my numbers might look like some of your handwriting. Make it neater than that, please. All right, so I'm not going to walk through the process for each of these, but I will get it balanced and I will show you what it reads, and then you will have to just read the graduated cylinder to find the mass, or sorry, read the triple beam balance to find the mass. Here's the large graduated cylinder. Sorry, this is really quite awkward to try to hold this camera. It'd be nice if I had like a production assistant. All right. That's not good. I might have done something wrong. Give me a moment. Yep. Okay. Here is the large graduated cylinder. I'll leave it on there for a second. You can always pause the video if you need to. Remember, we're trying to measure to the nearest 1/10 of a gram. If it's right on a line for the ones place, you'll still include the decimal, but it'll just be 0.0. All right, that was the large graduated cylinder. Now it says ruler. I'm using a 1/2 meter stick, but that'll do. Less than 100 grams. Less than 50, but more than 40. Oh, this wasn't quite set to 0. Hopefully that doesn't. There we go. And for our ruler, you can pause it here if you need to. Okay, resetting it to 0. Your pencil. I just knew that that was less than 10 grams, so I went straight for it. All right, and you can go ahead and cross out the last two because I'm trying to record this right before second period starts, and I'm going to run out of time. So you can cross out those last two boxes, and I'll just show you the last little bit. So there are some questions about mass, just asking you which unit would be most appropriate for measuring three different things. If you were going to measure your own mass, which unit would be kind of the best to use to give you the most reasonable numbers? Or for the amount of spices in a batch of cookies and the mass of 10 pennies, just to kind of see if you have an idea for the sizes of these different units. Each one is only used once. And finally, this last question asks you to write a procedure for how you could find the volume, or sorry, how to find the mass of 100 milliliters of water using these tools that you have available. So you can look at that materials list at the beginning of this document. Don't worry about finding what the actual mass is. You can cross that out. But I just want you to write a step-by-step procedure for how you could find the mass of 100 milliliters of water. I'll tell you right now, you can't just measure 100 milliliters and pour it onto the pan. That doesn't work. And you can't just fill a graduated cylinder to 100 milliliters and put it on the balance, because then you're getting the mass of the water and the cylinder. So you'll have to come up with a way or a procedure, step-by-step directions on how you could find that mass of just 100 milliliters of water. All right, thank you for watching this video. Sorry you couldn't do the lab with us. Hopefully, eventually, we'll all be back in school normally. All right, and have a wonderful day.